we are going to look today at a 2x4 base, and we're going to document what's wrong with it. Long story short, the gentleman says he sounds crunchy on sideband, said smoke coming out the box, all sorts of different stuff. I can't find where the smoke's coming from, but I think I figured out why you're a little crunchy on sideband. These are your bias resistors, and they knock down the 12 volt or 14 volt or 16 volt or whatever this unregulated power supply puts out for it to float at. They knock down the voltage. There's a diode on this end, a capacitor, a disc capacitor, a 10 ohm capacitor. Anyhow, that represents a load, and it knocks the voltage down to about half a volt, somewhere near, depending on who built it. But we're going to get down here and we're going to look at this input transformer. That thing is clean and mean and never been soldered to. And the reason I think that's kind of important is for you to be in Class B for sideband, you got to pull this voltage and attach it to this transformer. That's what they do here. See that? It's soldered directly to there. Well, we're missing that part. And as you can see, that's never been soldered to. So that would probably explain why it sounds like you're in Class C on sideband. The other problem is this one was cold solder jointed. You can see where it was just barely attached, but it's jiggled itself loose. So we're going to go in and we're going to repair that. We're going to add a choke to the input. We're going to pull these DEIs out. The customer wants to do that. He doesn't have faith in them, so I've got two matched Toshiba 2290s sitting here. And yeah, non-red dot, by the way. The good ones. We're going to pull these out and replace them with something that looks a lot like this, which can pass a whole effing tard more current. We're going to pull out this little 22 gauge fuse, which isn't going to help it make any more power, but it's going to make the box run cooler because the parts aren't going to be working so hard to get the power to do the job. That's open for debate. Let the haters hate and they can talk their faces off. Can you hear them out there? I'm not man enough to talk to you in person, so I do it on a keyboard. Let them talk. Let's take it apart. Let's build it back up. And I bet you it runs just a little bit better for us. We'll see. Anyhow, she's done. Added a choke, right? Replace the transistors with a matched pair of 2290s. Played with the input tune for a minute, played with the output tune for a second. Actually added wire to carry the current. It's laying right next to each other, check that out. Okay, place the driver power wire right here, like this, right there. Let's file that too. And over here on the transformer, this is what I've never understood. We're going to take 12 gauge coming in from the power cable, and then we're going to run it through 22 gauge wire, so you can see the size difference. 22 gauge wire, and then you're going to run it all the way across the box through the power switch back to the transformer. So I went ahead and I replaced it with 12 gauge stranded, and that's right there, 12 gauge stranded, and heat shrinked it all up so it looks all nice and pretty, all nice and straight tight runs. And And, well, proof is in the pudding. So that's the variable all the way down. And once again, how this works is the first switch is PEP. The second switch in the middle position is 1X, up is 2, and down is 5. All that does is change the face value of the slug. So our 1X PEP is a 1,000 watt slug. 1,000 watt slug going forward in RMS mode, and there's no peak kits. We're going to run it with the Galaxy 66. We're going to hit it with, well, hello, audio. Hello, audio. About 18 watts worth of drive. Variables all the way down. Key to box. So they're reading exactly the same. So we're throwing a, what? About 300 watt dead key, 280 watt dead key. Hello, audio. Swinging at 400. What we're going to do is we're going to turn this to about half. Hello, in a corner. Hello, in a corner. So we're seeing this go to about 500 watts RMS. We're seeing it bury the scale over here on the left. So it is, I reached over and I put this into the 2X position. So now this is reading like a 2,000 watt slug. The 2,000 watts, halfway on the meter is right there at 50. 40, 50, 100, okay. Halfway 50, it's 1,000 watts right there. Over here's 2,000, so 1,000, 12, 14, 16, 18, 2,000. I bet we're going to end up right about in here, 12, 1,300 watts. Hello, audio. Hello, audio. Hello, audio. Run for max dead key. Right? Pretty impressive. So back this down to where it's just under a 400 watt dead key. Hello, audio. Hello, audio. Hello, audio. Seeing 425 watts RMS and 1100 peak. And what I'm going to do is I'm going to fire up a striker and I'm going to run it into this and we're going to hit it a little bit harder and see what we get. Okay. Striker 955. Hello, 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 hello. Hello, hello. 0 for reflect. Input tune spot on the money. Changed out a 1,000 watt slug to a 5 watt slug in reverse to show the output tune. And we're still in 2X PEP on the right hand scale. Hello, audio. Hello, audio. Yeah, we're seeing like 1350 and some change. Hello, audio. Output tune is spot on the money. Let's turn on the sideband. Go up here and go to lower side, and I gotta turn the power up on that. Hello, audio. Hello, audio. Hello, audio. Needless to say, it's working like a top. It's all fixed up, John. I'm gonna call you tonight, we'll get squared up. My name is BBI, and I am the biggest mud duck in Idaho. Check us out, www.bbiamps.com. From there, it'll link you to everything else in the universe. I appreciate everybody's support, and let the haters hate. Nobody hate back. It ain't worth our time. We'll see you by. One more Duke, 10-8.